All right, so I'm going to look at the 2024 Northern Hemisphere Methods exam, and this is the extended response section. So this is all calculator active, and it's generally more application type questions. So let's have a look. Question 1, consider the function f of x equals x cubed minus px, where p is an element of all real numbers. Part of the graph of f is shown below when p equals 3. Find the values of the x-intercept when p equals 3. Okay, so what we would have is we'd have x cubed. The pen is way too thick. X cubed minus 3 minus 3x minus 3x equals 0 because we need to know the x-intercepts. Take out x as a factor, so you're left with x squared minus 3 equals 0. All right, applying the null factor law, either x equals 0 or x equals plus or minus root 3. Okay, it doesn't say coordinates, so I think that would be okay as an answer. Use the derivative f dash to find the coordinates of the turning point of f when p equals 3. All right, the derivative. So the derivative would be f dash of x is going to be, just can't see it, 3x squared minus p. Okay, find the coordinates of the turning point. So the turning points are when the derivative equals 0. So we're going to have 3x squared minus p equals 0. Okay. Why am I doing that? Okay, I'm not sure why I didn't sub in p being 3. So the derivative is 3x squared minus 3. Find the coordinates of the turning point. So this has to equal 0. So 3x squared minus 3 equals 0. Take out 3. Let's just add 3 to both sides. We get 3x squared equals 3. So x squared equals plus or minus 1. But it does say find coordinates this time. So sub that back into the, and that is not good enough notation. X equals plus or minus 1. Okay, so sub that in. So you're going to get, let's sub in -1. So we're going to get -1 cubed minus 3 times -1, which equals, -1 cubed is -1 plus 3 is 2. So one of the coordinates is -1, 2. -1 cubed minus 3 times -1 is -1 plus 3. Okay, that looks okay. What about +1 cubed minus 3 times 1? That's 1 minus 3, which is -2. So what's that? The other one is at 1 -2. I think that looks reasonable because it all looks very symmetrical if we look at it over there. Okay, let's check because we can. If we go menu here, what was the graph? X cubed minus 3x. Yeah, -1, 2, and 1, -2. Is that what we said? -1, 2, and 1, -2. -1, 2, and 1, -2. Yeah, I reckon that looks good. So, and we've done it as coordinates. So I reckon that's the answer. Okay, next thing. Find the value of p for which f would have exactly one stationary point. Okay, find the value of p. So p is not 3 anymore, which f would have exactly one stationary point. So f dash of x, let's just remind ourselves, is now going to be in terms of p. So it's going to be 3x squared minus p. Exactly one stationary point. So the discriminant of this equals 0. So remember, I have one stationary point. The discriminant equals 0. So let's work out the discriminant. The discriminant is b squared minus 4ac. So it's going to be b squared. So that's b squared. So that's 0 squared minus 4 times 3 times negative p. And we need that to equal 0. So what do we get? We get negative, so we get 12p equals 0, in which case p equals 0. We probably could have just thought about that. If p was 0 here, we just get x cubed, and x cubed would have one stationary point. So I think that looks fine. Why not do it? Let's do it. So let's put in a slider for p minus px, p times x. Yeah, so we can see when p is 1, we have multiple stationary points. When p is 0, we have one stationary point. And the next questions are going to ask, when is there no stationary points? Well, if p is less than 0, see, we get a situation where we're not going to get any stationary points. So find the values p for which does not have any stationary points. Well, the discriminant is less than 0, in which case p is less than 0. Okay, I think that sounds about right. The graph of f passes through the origin for all values of p. Use calculus to show that the tangent line to f at the origin has the equation y equals negative px. Graph of f passes through the origin for all values of p. Okay, yes. Use calculus to show that the tangent line to f at the origin has that equation. Okay, I think I get it. So what we're saying is f dash of x, if we can recall, is 3x squared minus p. So the tangent line to f at the origin. Okay, so at the origin, the f x value is 0 at the origin, right? So f dash of 0 equals negative p. So the gradient of that function at the origin is negative p. So what we can do is we can set up y equals mx plus c as our linear line. We know that m is negative p x plus c. Okay, we don't know what c is, but c is going to be 0 because at the origin on the original function, we know that when the y value is 0, we get negative p times 0 plus c. So the x value is 0, the y value is 0 at the origin. So sub that in, and clearly, hopefully you can see, you get c equals 0. Therefore, y equals negative px is the tangent. And why not? Because we've got a calculator. Let's put that in. Y equals negative px. Let's graph that. And that looks about right. It's dynamic graph it. That's always a tangent there. Hopefully you can see that at the origin. Cool, so that looks all right. Find in terms of p the area of the region bounded by the function, the line y equals negative px, and the line x equals p, where p is greater than 0. Okay, so it's going to be the integral, the area of the region bounded by the function f, the line y equals negative px, and the line x equals p. Okay, so we're going to take the integral from 0 to p. What's the upper function? We zoom in. Why does it not let me grab it? Okay. I think the blue line for p greater than 0. P greater than 0. In tiny terms, be the area of the region bounded by the function, the line y equals p negative px, and the line x equals p. P is greater than 0. Okay, what I've got here is that we have to do this. I've done this before. I'm just trying to work out what I did. X cubed minus px minus negative px. Okay, so so this is the upper function, which is the original function, minus that function between 0 and p, dx. Find in terms of p the area of the region bounded by the function f, the line y equals negative px, and the line x equals p. The area of the region bounded by the function. Okay, yeah, that's right. It's just you got to have a visual picture of what's going on. So yeah, if you put in a line at P, you get something like this. So it's sort of, I think what it's asking for is this region in here, where yeah, and it wants you to find that area. And so the region gets larger if P is larger. Okay. So we put that in our calculators. So if we go mean, let's define x cubed minus P times x. Make sure you use the multiplication sign. Interactive, define, let's define that as f of x. Let's just check that we did that right. See, P for some reason is 2. So you just gotta be so careful. So variable manager, delete all your variables. Delete all of your variables. Okay, let's close that. All right, so let's redo this. Now press enter. Now check that it's what we want. That looks good. Okay. We need to do the integral. Definite integral from 0 to P of P of x, f of x, which is what we had before, minus negative P times x. So that's P to the 4 on 4. Okay. Okay, I think that seems about right. The expression for the area found in part D2 also gives the area bounded by a cubic function, y equals x cubed. The x-axis in the line x equals p, where p is greater than 0. Find all possible values of k. Okay, so what it's saying is the integral from 0 to some point p of kx cubed dx is equal to that. It's equal to p to the 4 on 4. So if we solve that, so we're going to go interactive calculation. Let's just get the integral sign. What are we doing between 0 and p? Expression k times x cubed. Okay, so this thing needs to equal p to the 4 on 4. K equals 1. I don't know why I'm solving this. K is obviously 1. Solve K. K equals 1. I'm very concerned about that word, all possible values of K. Let me have more of a think. Yeah, I'm not sure if I've made an error there, but just that word all, find all possible values of K makes me think that I've missed something. I've only got one value of K. Anyway, let me know if you think I've got something wrong there. Question 2. A simple pendulum consists of a mass at the end of a string of fixed length 0.5 meters. The other end of the string is attached to a fixed point O. The mass swings back and forth in a circular arc between A and C, each time passing through point B. The height of the mass above the horizontal ground is given by this function, where theta is the angle in radians measured anti-clockwise from the vertical. OB, the mass reaches its maximum height at point A when theta equals pi on 3, and at point C when theta equals negative pi on 3. It reaches a minimum height at point B. That makes sense. Find the maximum and minimum heights of the mass in meters above the ground. Okay, so hopefully this one's not too bad. Maximum and minimum of a sine function, of a cosine function rather, is, so the maximum is always the mean line plus the amplitude. So the mean line has been shifted up 3 on 2 plus the amplitude, which is 1/2. So I reckon the maximum's at 2. I reckon the minimum is at 3 on 2 minus 1/2, which is 1. If I correct to 2 decimal places, values of theta for which the mass has a height h less than 1.1. Okay, so we're going to define this on our calculator. So let's go do that. And these can be tricky because it's a sine function. So what is it? It's solving trigonometric inequalities can be tricky on the calculator. So 3 on 2 minus 1/2 of cosine x. We're just going to use x. Okay, let's define it without a domain. Let's define that as f of x. Make sure we did it right. 3 on 2 minus 1/2 cosine x. Okay, that looks good. Won't go to a lot. Okay. The values of theta for which this one's not too bad. The values of theta, so this thing, so f of x needs to equal 1.1, but only between, and make sure you're in radians, but only between negative pi on 3 and positive pi on 3. Because that's the domain, yeah? All right, we're going to do interactive advanced solve all that, solve it numerically, solve it for x. And see, this is what happens. It gives me a general solution. So I reckon it's the way I wrote it. I reckon this. Oh, I missed that. Okay, that looks better. Negative 0 points. I missed the inequality sign. So negative 0.64 and positive 0.64. How many decimals does it want? 2 decimals. So theta, remember everything was in theta, equals negative 0.64 and positive 0.64. Yeah, check the rounding. Yeah, the rounding's fine, but my answer's not fine because I would lose a mark, I think, because I didn't show what I solved. So what we're going to just write is we're going to write h of theta equals 1.1 and then say theta equals less than. Okay, let's go back for a second. Less than. This is where I think the calculator doesn't like it. Okay. See how it gives us a general solution here? It's got this constant in there. So what you need to do, I've encountered this problem before. I think you need to sketch it. So if you go graph and table, if you graph f of x, undefined variable, of course there is. Why is there an undefined variable? Shouldn't be. Okay, go back. Let's try that again. What is f of x? Oh, because I'm in that. And that's still in that for some reason. Let's put it in this one. So particular. Then again, I need to tell it what I want it to do. Otherwise it doesn't know. Okay. Less than 1.1. So now if I put a line at 1.1, graph that. Okay, but I'm only interested between negative pi on 3 and pi on 3. So I've got to put a domain in here. Negative pi on 3, positive pi on 3. Why is that going forever? Okay, so yeah, I just didn't put the domain in properly again, so it didn't work. So yeah, you should get something like this, which makes a lot more sense. This is at negative 0.64. This is at positive 0.64. So when is it less than 1.1? Well, between negative 0.64 and positive 0.64. So less than 1.1. So I reckon the answer is for theta, as long as theta is less than 0.64 and greater than negative 0.64. Mass has a height less than 1.1. Yeah, that makes sense. When it's closer to B, the height is smaller. Okay, I think that checks out. Okay, the next one. The angle theta radians as a function of time, t seconds, is given by the function S. Show that the mass is initially at point A. Okay, initially should jump out at you. So we're just subbing in 0 essentially. So theta of 0 equals pi on 3 cosine of 9 on 2. What am I talking about? That's not right. 9 times 0 is 0. So cosine of 0. So this is at pi on 3, which is at A. Because if you look up here, that's at A when the angle's pi on 3, which makes sense. Determine the period of the pendulum. Okay, this one doesn't look too bad. Remember, the period is always equal to 2 pi for a cosine or sine graph divided by the coefficient. 2 pi of t in this case. 2 pi divided by 9 on 2 is 4 pi on 9. How many times is the mass at point A? Yeah, so how many times is the mass at point A? Well, we know that when it's at point A, the angle is pi on 3, positive pi on 3. So we just need to solve this equaling pi on 3 between 0 and 30 and see how many solutions we get. So let's go to a main page. Let's clear all this. Okay, what is the function? I already forgot. Pi on 3 cos. Okay. Pi on 3 times cosine of 9. Let's do x on 2. Okay, I need that to equal pi on 3 because that's when that's when it's at. When it's at A, right? Because I'm given x. I need to find out how many x solutions we've got. So we're going to attractive, advanced. Advanced, solve. Let's solve that for x. It's going to give us a general solution. But what I want is this, and then I'm going to put the domain in. So I'm going to say it needs to be between 0 and 30, and press enter. Okay, and this is not trivial to count all these. So if we put it in standard mode, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I'm not at all confident on that. Let's rotate this. And that doesn't help because then you can't turn it in real life. Okay, I'm going to cheat a little bit. I'm going to go resizable mode. I'm going to cheat. You can't do this on an exam, but I'm sure you can hopefully get the idea. You just need to count all these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I did count wrong the first time. So there is 22 times that it's at point A. Okay, so you just got to count that very carefully. So I reckon the answer to this is 22. Okay, determine the distance in meters that the mass travels as it swings from point A to point C. I was stumped on this the first time I did it, and I don't know why. It's actually not that difficult, I don't think. But you have to sort of pick up that. Remember, we're on a circle here, and this has a radius of 1.5 meters. And this angle here, just for simplicity's sake, is 60 degrees, and then this is 60 degrees, right? So we're subtending 120 degrees across this arc. So I reckon this is basically a circumference question. What is the circumference of a sector of a circle when you're subtending 120 degrees with a radius of 1.5? So let's think about that. We know that the circumference of a full circle is 2 pi r. So the circumference of a sector will be 120, 360 multiplied by 2 times pi times the radius. Well, the radius is 1.5. Determine the distance in meters. Okay, it wants an exact answer. So what's that? 120 on 360 is 1/3. So it's 2 pi on 3 times 3 on 2. So what's that? 9 pi on 6, which is 3 pi on 2 meters. I think that sounds about right. Let's check 120 on 360. 120 divided by 360 multiplied by 2 pi times 1.5 is pi. Can I just not do maths? Oh, where did I go wrong? Always check when you got a calculator, use it. 1/3. That's definitely 1/3, isn't it? It's 1/3. Probably screaming at the screen right about now. 1/3 multiplied by 2 pi multiplied by 3 on 2. That goes with that. That goes with that. I don't know how I got that wrong the first time. Anyway, pi, that looks a bit better. Okay, pi meters. I'm not going to bother with why I got it wrong. It'll be something small. Okay, anyway, find correct to 2 decimal place the height of the mass in meters after 1 second has elapsed. Okay, what can we do here? So we need to know the angle after 1 second. You would agree? So we need to know the angle, so theta of 1. So we need to substitute 1 into here, because then that'll tell us the angle after 1 second. So it's pi on 3 times cosine of 9 on 2. Which is whatever it is, that's the angle. Then we need to sub that into our original function, which is h. So essentially what we're doing is we're finding h of pi on 3 cosine 9 on 2, which, did I define my function? Did I call this f of x? Let's go back. F of x, what is that? Yes, that's a win. It's still defined as f of x. Okay, what are we subbing in? We're subbing in pi on 3 cosine of 9 on 2. And we want it as a decimal 1.01. So I reckon the answer here is 1.01 meters. State the rule for the composite function, h of theta of t. Okay. I feel like I'm falling into lots of traps in this exam, but can you do? You just do your best. So negative a half cosine. So what we're doing is I'm taking the h function, and wherever there's an x, I'm going to put theta of t, essentially. There's going to be pi on 3 cosine of a 9t on 2 plus 3 on 2. That 3 on 2 is outside the brackets. Okay. Something feels off about that, but that's what I think it is. Find corrected 2 decimal places the average height of the mass in meters. Okay, the average height of the mass is just going to be the average value of the function, h of t. Okay, so remember, average value of a function, you have to do the integral. So the domain is negative pi on 3, if you think back to it, to pi on 3. Okay, 1 over b minus a. So it's 1 over b minus a. So it's negative, so it's pi on 3 minus negative pi on 3. Okay, and that's the integral of h of t dt. So this is the integral. All right, this is 2 pi on 3. So this whole thing becomes 2 on 3 on 2 pi. The integral from negative pi on 3 to pi on 3 h of t dt. Okay, let's go do that. So 3 on 2 pi multiplied by the integral. Can I just get an integral sign? Is it going to let me do that? Sort of take that down. Okay, the integral from negative pi on 3 to pi on 3. Pi on 3 f of x dx is 1.09 meters. That seems reasonable, I think. The average height of the function. Yeah, I think that sounds about right. So it seems like a reasonable answer. Okay, let me know if you think any of that is wrong. Okay, small business has 4 people working full time. The business rents an office, and on most days, some people work from home. On any given workday, the number of people working in the office can be modeled by the discrete random variable n, following probability distribution. Find the expected value of n, the expected value for the number of people working in the office. Okay, to find the expected value of a discrete random variable, you need to take this times this, plus this times this, plus this times this, plus this times this. How do I know that? Oh, yeah, won't go into it. But it's obviously there's very good reasoning behind it. Plus 3 times 0.2 plus 4 times 0.1. Okay, you crunch those numbers and you get 2.1, I think. So you would expect number of people working in the office on any given day to be 2.1. Okay. Find the probability that all 4 people are working in the office, given that at least 2 people are working in the office. Okay, so this sounds like conditional probability. So what's the probability that all 4 are working in the office? So n equals 4, given that n is greater than or equal to 2. Okay, so that's just the probability and just applying our conditional probability rule, and n is greater than or equal to 2 divided by the probability that n is greater than or equal to 2. Okay, then you have to ask yourself, what is the intersection of these two things, right? Well, they intersect only at n equals 4. So that top numerator thing is just probability n equals 4 divided by the probability that n is greater than or equal to 2. Okay, so the probability n equals 4 is 0.1. The probability n is greater than or equal to 2 is 0.4 plus 0.2 plus 0.1 is 0.7. That's 1/7. So I think the answer is 1/7. In a fortnight with 10 workdays, find the probability that all 4 people work in the office on at least 3 days. Write your answer correct to 4 decimal places. Okay, this to me is sounding like it's binomially distributed with 10 workdays. Find the probability that all 4 people work in the office on at least 3 days. Okay, so we're trying to find this. We're trying to find the probability that x is greater than or equal to 3. Okay, which is going to be equal to 1 minus. Okay, so being greater than or equal to 3 is the same as being 1 minus the probability x equals 0, 1, or 2. I reckon that's what we need to work out. So let's work out each one individually. So probability x equals 0. Okay, so that means from the 10 possible days, 10 choose none of those days. The probability of success in a fortnight that all 4 people are working here, the probability of success is 0.1 raised to the power of 0 multiplied by 0.9 to the power of 10. Because yeah, out of the 10 days, we want none of them. Yeah, and then the probability of success of having all 4 people there is 0.1. Okay, maybe we'll do the next one as well, and hopefully I'm on the right track here. Probability x equals 1. Okay, so from the 10 days, am I even getting that right? Is it 10 days? In a fortnight with 10 work days, so the probability that all 4 people are working in the office at least once. 10 choose 1. 0.1 to the 1. I'm 0.9 to the 9. And this last one's 10 choose 2. Yeah. So the 10 choose 2 part is like people could come in on the Monday and the Tuesday, they come in the Monday or the Wednesday, the Monday or the Thursday. So there's 10 choose 2 ways for 4 people to come in on those different days, I think. I don't know, I'm not explaining that very well, but I think it's right. It's a power of 8. So then this is, yeah, we need to use our calculator now. So this is just 0.9 to the power of 10 because this is equal to 1 and this is equal to 1. Okay, so let's go to our calculator. So we're going to get 0.9 the power of 10. Our first one. Okay, then they're going to add on. Okay, go down here. Okay, NCR 10 choose 1 multiplied by 0.1 multiplied by 0.9. 0.9 to the power of 9. Okay, plus N choose 2. N choose 2 by 0.1 to the 2 of 2 times 0.9 to the power of 8. I think this matters, but I'm going to do it anyway. So we get 0.9298. So all of these added together equals 0.9298. So 1 minus 0.9298, and let's not skimp on the decimals, 9809. So if we put that in, so we do 1 minus that, right? Because the whole thing is 1 minus all that. 0.07. 0.0702 to 4 decimal places. Okay, let me see if I can explain that better. Yeah, so maybe I'll just add, which I should have said at the start, that, we're saying X is binomially distributed. Yeah, and it represents, a success represents 4 people being in the office on one day. I could be confused about this. So let me know if you think I've done something wrong there. Potential. The business owner is trying to find ways to reduce costs. So daily electricity cost in dollars can be modeled using a continuous random variable C, which is the probability density function. That identify the maximum daily electricity cost in dollars for this business. Okay, so 3C, let's define it. Let's clear all this. Okay, so what is it? It's 3C times 3x times x minus 10. Squared divided by 2500. Directive, fine, g of x, okay. Identify the maximum daily electricity cost. Okay, we could do F max. So we could write g of x. Directive. I always forget where this is. F max. Okay, yep, because I didn't put the domain in, which I needed to. It says in the question that the domain is 0 to 10. It's killing me. Why is that not working? Graph it. Watch this not want to work for me either. I'm going to lose my mind very shortly. Is that even what I typed in? Where did that extra bracket come from? Do not know why there's a bracket there. I'm slowly going crazy. Let's delete all that and let's try again. 3x multiplied by x minus 10 squared, all divided by 2500. Directive, define f of x. Let's try that again. F of x. Maybe now it will work. Interactive. And I probably need the domain. Let's put the domain in here. 8/45 as the maximum value. Okay, that's what I got before. 8/45. On mark. Find the mean daily electricity cost in dollars. Okay. Continuous random variable. Okay, you have to look at your formula sheet, but for a continuous random variable, the mean is given by the integral from the boundary, x multiplied by f of c. C multiplied by f of c, dc. And that equals, okay, I'm going to take f of x, interactive calculation, integral, definite from 0 to 10. And I'm going to multiply by x. The answer is 4. Find the probability that on a given day, the electricity cost is within 2 standard deviations of the mean. Okay, again, have a look at your formula sheet. We know it gives you the variance. The variance is the integral in this case from 0 to 10. Okay, and it tells you on the formula sheet, but basically you got to do this. You take on the formula sheet, it will say x minus the mean. So in our case, it's going to be c minus 4 times f of c dc. And if we work that out, so let's take this. It's very similar to this, isn't it? It's going to be x minus 4 squared. The answer to that is also 4. So that's the variance. So the standard deviation must be the square root of 4, which is 2. Okay, electricity cost within 2 standard deviations of the mean. So the mean is 4. Mean is 4. So I don't know, we've got some function, right? The mean is like here somewhere, 4. 2 standard deviations above that would be at 8 because the standard deviation is 2, and 2 below that would be 0. I reckon you need to take the integral from 0 to 8 of f of c dc. And that gives you an answer of the integral from, let's take this again, integral from 0 to 8 f of x dx. Is that what I'm trying to do? Yes, I think it is. 608 on 625. That seems like a large probability, and generally you expect your probabilities to be quite large if you're talking about within 2 standard deviations of the mean. Okay, I think that looks okay. The business owner plans to reduce electricity costs by installing LED sensors. She researches an LED sensor manufacturer and finds the following information. In a random sample of 200 LED sensors, 30 LED sensors were found to be defective. State the sample proportion of LED sensors that were found to be defective. Okay, so from the 30 of the 200 were defective. So I reckon that's just 3 on 20. So I reckon that's the sample proportion. Okay, use this sample proportion to find a 90% confidence interval for the population proportion of defective LED sensors. Correct to 3 decimal places. Okay, so use the sample proportion to find a 90% confidence interval for the population proportion of defective LED sensors. Now, a 90% confidence interval, you have to have a certain Z value. So if we go to the formula sheet, you can see that the approximate confidence interval is equal to the sample proportion minus Z multiplied by the square root of the sample proportion multiplied by 1 minus the sample proportion, all divided by N. So as far as I'm aware, you have to use, this has to be something that's on your cheat sheet, essentially, or on your bound reference. But as far as I'm aware, you have to use a Z value of 1.64 is considered a 90% confidence interval. So what you need to do now is you need to apply that formula. So if with using a sample proportion of 3 on 20. So if we go to our calculator, 3 on 20 minus 1.645 multiplied by the square root of 3 on 20 multiplied by 1 minus 3 on 20, which would be 17 on 20. Divided by 200. We want it as decimal, 0.108. The 3 decimal places. And we want to change these to pluses. We just want to change this to a plus now, because the other one is at plus. $1.192. Now I just realized I used 0.645. Hopefully it doesn't give a different answer. This one would be different. Which one do I use? 108. This one would be 109 as well. Okay, I reckon you have to use 1.64, so I'm going to go with 1.09. 1.93, is it? 191. Okay. Need to think about that maybe a bit more. Let me know what you think. A new sample size N is taken, which is used to calculate a 95% confidence interval for the population proportion of defective LED sensors. This confidence interval, corrected 3 decimal places, is 0.062 and 0.213. Using the value z equals 1.96, determine the sample size N. Okay, we'll come back to F in a second. I just realized that part 2 here can just be done using the calculator, so there's not going to be any rounding errors. So I'll show you what I mean by that. If you go to statistics, which is here, and then you go calc interval, all right, 1 prop z interval, and then go next. We wanted a confidence level of 90%. And out of the 30 sensors, 200, sorry, out of the 200 sensors, 30 were defective. So we get very similar answers, but this answer is 0.108 and this one's 0.192. So 0.108, 192. Okay, I still have to think about F. Okay, I'm gonna have to make another video about that sampling question. It's not my strongest topic, so I need to have a look at it. Okay, Timothy has created a tiling pattern using transformations of the cubic function -4 to 0, f of x equals this. On the graph below, the function is shown in bold. The rest of Timothy's tiling pattern is shown with dashed lines, which are all images or transformations of f. The translation of f given by f2 of x equals f of x minus 4 describes a different edge of one of the tiles. Trace over the edge described by f2 on the graph in figure 1 and label this edge f2. Okay, it's been moved to the right by 4 and it's been moved down 4. So let's see what that looks like, if my pen will work. Of course it doesn't want to work. There you go. So it's this part here, isn't it? Move this point, just pick any point and move it across 4. So 2, 4, and then down 4. So it's this part here. So that's f of 2. It said label it. Given that f has a stationary point of inflection at -2, 2 and an axial intercept at 0, 4, find the values of a, b, and c. Okay, so it has a stationary point of inflection, so it has this graph, right? So we could say f of x equals a times x minus 2, because it's been moved to the left 2 cubed plus 2. So the stationary point of inflection is kind of like cubic stationary point of inflection form, right? And we also know that when f of x equals 4, we got a times 0 plus 2 cubed plus 2. So solving this, we get 4 equals 8a plus 2. So a equals 1/4. So therefore, we're going to write it. Find the values of a, b, and c. All right, well, a is 1/4. B is, okay, gotta be careful here. B is -2. And C is +2. Piecewise function, the piecewise function P is continuous, where the first component is F, the other component is a translation of F, and both are edges in Timothy's tiling pattern. Complete a possible rule and domain for the second piece of the piecewise function P. All right, it has to be continuous, where the first component is F, the other component is a translation of F, and both edges are in Timothy's tiling pattern. Okay, maybe a different color here will help. So maybe if we took this one, so it needs to be a translation, but it also needs to be his tiling pattern. So, we're moving this to the left 4 and then down 4. So I reckon there's lots of acceptable answers to this, but I reckon one of them is this. Move it to the left 4 and then move it down 4. And the domain of that line would be from -8 to -4. But I reckon there's lots of answers to that because you could translate it to any of those other tiling patterns. Find the rule and domain for F inverse, the inverse of F. Okay, let's go back to our royal blue. Find a rule for the domain of F inverse and the inverse function of F. Okay. We know that y equals 1/4 x plus 2 cubed plus 2. Okay, swap x and y to find the inverse, right? So you get x equals 1/4 y plus 2 cubed plus 2. So, try and solve this. So you get x minus 2 equals y plus 2 cubed on 4. So you get 4x minus 8 is y plus 2 cubed. I'm doing a lot of steps here. All right, I'm going to do 2 at once here. The cube root of 4x minus 8 minus 2 equals y. Find the rule and domain. So f inverse of x is equal to the cube root 4x minus 8 minus 2. Okay, what's the domain? Well, the domain of the inverse is the range of the original. Range of the original is 0 to 4. The domain of this is 0 to 4. I think that's okay. I think that looks all right. Let m and n be an element of all real numbers, and g of x equals m multiplied by f inverse of nx be a function describing a transformation of the inverse. Find the values of m and n given that g of x describes the tile edge joining -4, 0 and 0, -4. Okay, this is where it can get hard. You can get lost in the wording. So g of x is a transformation of the inverse of f of x. Find the values of m and n given that g of x describes the tile edge joining -4, 0 and 0, -4. Okay. Let me think how to explain it. Right. So we really need to wrap our head around what the graph looks like. So if we graph that, 1/4 x plus 2 cubed plus 2, if I zoom out. Okay, but I only want that between, so this is part of his tiling pattern, right? So I only want that between -4 and 0. Graph that, so that looks a bit better. Okay, the next part is you need to graph the other part, which is the inverse, right? So the inverse was the cube root of 4x minus 8, I think. 4x minus 8 minus 2. Minus 2, but I only want that. I only wanted that between 0 and 4. Kick it on. Okay, so that's the inverse. Okay, so what it's saying is we need to transform that inverse. Okay, yeah, so the inverse function is just this part here. Yes, very good. We need it to map onto this one. So to me, that looks like a reflection in the y-axis. So I think what they want us to write, find the values of m and n. So m, if we changed m or made m negative, it would be a reflection across the y-axis. So we don't want to do that. So we're going to leave m as 1. And we're going to do n being negative 1. Okay, and so essentially what that means is we're making this x value in here negative. And if we resketch it, but now we've got to think about the domain, right? It's -4 to 0. And then that gives us that part of the tile. So I think that's right. M is 1 and N is -1. Find the area of one of the tiles. An example is shaded in figure 2. All right, find the area of that tile. Let's just find the integral from, let's say, -4 to 0. So let's just find this area and then multiply by 4. So 4 times the integral from -4 to 0 of f of x, because that's the line f of x, isn't it? And if we go and do that, let's take this because this is f of x. And we place that there and we highlight that. What am I trying to do? I'm trying to integrate it. Definite integral from -4 to 0. Gives me an answer of 8. I'm going to multiply that by 4. So there's 4 of them. So that's an area of 32. Using the derivative of f and g at x equals -4, show the angle at the left corner of the shaded tile at the point -4, 0 is 90 degrees. Using the derivative of f and g at x equals -4. Okay, let's just remind ourselves what f of x is. F of x was 1/4 x plus 2 cubed plus 2. So f dash of x. Okay, we can probably do this reasonably quickly in our heads. So it's going to be 3/4 x plus 2 squared multiplied by the derivative of the inside, which is 1. So I think it's just that. Okay, we want to know what is the gradient at -4. So f dash of -4. So what's that? -4 plus 2 is -2. -6 on 4. Yeah, I got to square it. -4 plus 2 is -2 squared is 4. So this is just 3. Okay, g. Let's remind ourselves what g of x is. G of x is the inverse of f reflected in the y-axis. So g of x is this, but -x. So it's the cube root of -4x minus 8. I've already forgot. Cube root of -4x minus 8. Cube root -4x minus 8 has been reflected in the y-axis, right? Minus 2. Okay, hopefully that's right. All right, g dash of x. I'm feeling less brave now, so I'm going to go back here. Let's take this. This is what we wanted. let's copy that. Go back to the main, click that, paste that there. Interactive, advanced, calculation. I want to diff that. I want it as that, whatever that is. So that's g dash of x. And I want to know what that is when x equals -4. It's -1/3, which is what we want. So g dash of x, would I need to write it? I'm going to write it -4 on 3. -4 on 3 times -4x minus 8 times 3 times -4x minus 8 to the 2/3. Oh, that's a 2. Oh my God. Okay, so g dash of -4 equals -1/3. And this is getting out of hand. Okay, therefore, 3 times -1/3 equals -1. So they're perpendicular. Therefore should be there. Therefore should be here. Therefore, oh yeah, what would you say? They're perpendicular. Okay, because one of them is the negative reciprocal of the other. Hopefully that's enough to get you full marks. Family of functions f can be defined by y equals g times x minus 8k. A k is an integer, gives an infinite set of edges in Timothy's tiling pattern, 3 of which are shown in bold in figure 3. 3 more families of function can be used to bound an infinite set of tiles centered on the x-axis, 3 of which are shaded in figure 3. Complete the table to define 3 such families of functions in terms of the given functions f or g and parameters k. Okay, again, I reckon there's multiple answers to this. I reckon these are 3 acceptable answers. If we took f of x minus 8k, because this is f of x, minus 8 groups of k would get us to here, wouldn't it? Because this is separated by a distance of 8. And so is this. So I reckon that's one of them that would bound that edge. Another one, let's just do this all in terms of f. I'm sure there's answers in terms of g, but it says we can do it in terms of f or g. So I reckon this is also an acceptable answer. We reflect f across the x-axis, we would get negative x. Yeah, I think I can write either plus or minus here. I don't think it matters. Negative x. Let me write it better. So let's reflect it. Because plus or minus 8k, as long as k is an integer, it doesn't matter. So as long as I get the reflection, maybe I'll write it like this, plus 8k. Because I think that would give me a reflection across the y-axis of f. And then plus or minus 8k would get me to all the other ones. They'd get me to like this one and all the other ones. And I reflected it across both axes, I would get this. I would get negative f of negative x plus 8k. And that would give me all these ones. So I reckon that's hopefully an acceptable answer. Let me know what you think. Okay, we're almost there. Question 5. Show that the rule and domain for f inverse, the inverse function of f, is that. Okay, show the rule and domain for the inverse function. Okay, so let y equal f of x. So you're going to get y equals e to the negative ex. So x equals e to the negative ey. Okay, take log base e of both sides. Log base e of x equals I've got to write swap x and y. Surely they'll be right. Okay, and then e to the. Oh my god. So what are we left with? We're left with negative ey. So y equals -1 on e log e of x. So f inverse of x equals -1 on e log e of x as required. Show the rule and domain. How do I show the domain? Okay, so the domain, so the range of the original range of f would be okay, let's think about what that graph would look like. E to the negative s or e to the negative x. So just pretend e is just a number, right? So e to the -2x, for example, looks like it's a reflection across the y-axis. So it looks like this. So it has a range of 0 to infinity. Therefore, the domain of f inverse is 0 to infinity. I'm not sure. Hopefully that's enough explanation. Because the range of f is 0 to infinity, so the domain of f inverse is 0 to infinity. So I think that's hopefully enough. Well, that's the idea anyway. Graphs of f and f inverse are shown. The unique intersection point is also labeled. Find the exact area of the shaded region that's bounded by the graph of f inverse, and the coordinate axes. Okay, I reckon what you do here is you break this up into two regions. So let's do the integral. Okay, let's do the integral of f from 0 to e, 0 to 1 on e, 0 to 1 on e, f of x dx, plus the integral from 1 on e to 1 of f inverse of x dx. Okay, and that gives us, okay, let's go define these. So f of x is e to the negative ex. You got to use the right e. E to the negative e times x. Active. Let's define that as f of x. Okay, g of x is going to be f inverse of x, which is -1 on e log e of x. -1 on e log base e of x. ln of x, right? So let's interactive find that as g of x. Okay, so then we said we're going to take the integral from 0 to 1 on e of f of x, which is 1 on e minus 1 on e squared. Okay. 1 on e minus 1 on e squared plus, bring this down. I want that to be g of x, which is f inverse in my case, from 1 on e. Should use the right e to 1. 1 on e minus 2 on e squared. One on e minus 2 on e squared. I think that looks reasonable. Okay. So collecting terms, this plus this is 2 on e minus 1 on e squared, minus 3 on e squared. That's what I think.